By Prashant Mittal. He'll be diving into monitoring and alerting for applications, how to keep them how to ensure the reliability in all sorts of environments. He's a product engineer at Gojek, uh, who is a gamer and shoots down issues at environments these days. So a round of applause for our next speaker.
Hi everyone. Today I'll be talking a bit about monitoring, alerting, and debugging applications. I'm Prashant Mittal. I work as a product engineer at Gojek, and I currently working in DevOps. That's my Twitter handle if you want to get in touch with me. Okay, so what is Gojek? We are basically a hyperlocal transport, logistic, and payment startup. We are operating out of 14 cities currently in Indonesia. We have around 20 million downloads in Android and iOS combined. We have over 200,000 drivers on our platform currently using that. And we have like 12 bookings per second made on our platform, over 30 microservices running, and like over 1,500 VMs and increasing day by day. Okay, so what is system monitoring and why do we need that? So as our system grows, we cannot keep an eye out on each and every machines. So we need an automated service for doing us that for us. Okay, so what happens? Like we can have a monitoring system like our team shouting, "Oh, the site went down." That is cool, but not a very optimal thing to do. Cool. So our basic monitoring system provides us basically three things. It helps us in minimizing the production issue that we might face. It should avoid like raising false alarms, and we should be able to do all this by making the minimum effort that we possibly can. Cool. So what are the possible challenges that we might face while setting up a monitoring and alerting system? So these are the three major problems. First is the false sense of security. What do I mean by a false sense of security? Cool. So, okay, I have a site. I can set up a ping check on that and see if the site is up or not. A ping check will work, but not in all cases. What happens if a hacker comes in and replaces all the assets by like a kitten playing a violin? It is cool, it's cute, but not an optimal thing to happen. So this is something like a false sense of security. Second is lack of cohesive tools that exist in the in our environment. So all the cloud providers do provide a basic dashboard which gives us some matrix like the service is up or not, but those are not a lot of in-depth things that we need, like what is slowing the system down or why the system is down. We won't know that. Okay, so they don't actually have us covered. Cool. So the third one is wrong mindset. So many people might think that monitoring is pain, but it's actually not. I would like to say it's actually close to as testing. So testing actually helps us in identifying the problems before we push the code in production, and monitoring actually helps us identifying the problems when the code is in production. So we can use them as they come. Okay, so cool. On levels of monitoring, what level can we put monitoring on? We can assume our application to be a multi-level stack, starting from the application to the process level, to the server, to the hosting provider, and to the external dependencies. Okay, so coming on to the application level monitoring, we can basically have these 5 things that we can monitor in any system: the response time of our application, the throughput of our application, the error rate, the transaction time, and the exceptions or the error that the application is throwing. So for first 4 things, we basically use New Relic. It's a pretty cool tool and gives us a lot of in-depth information about all the things that we require on an application level. These are some example charts or the things that we get, the matrix. We get like web transactions, the throughput, the error rate, or each transaction, how much time is it taking. So it is pretty much in-depth thing, and we can go into more nitty-gritties of that. For error and exception handling, we use Sentry. It's a pretty cool tool. It has like a paid version and a free open source version as well. So you can host it on your premise, and it will be free for you. It has like notification systems in that, so you get an email every time your application has an error or a notification. So coming on to process level, all the applications that we have run on our server as a process, right? So we can have like a process check over on our machines, say our the process is up or terminated or whatever. For in Linux, we can use Monit for that. It's a pretty nifty tool, and it's pretty much what we use in Gojek. So coming on to the server level is like getting the matrix from the box, like how much CPU is getting used, how much RAM is getting used, what's the IO like, or if there is any weight on that. So these are some example charts that we have in our system. So we can see the load average on that, the memory breakdown. So, and we can set up for the alerts on the thresholds that we desire. Say the CPU should not go above 70% or 80%, or the memory should, like the disk usage should not be more than 90%. We get an alert on that. So we basically use Datadog for that. It's like it is a pretty vast tool, and it has got a lot of integrations with a lot of component that we have in our application, like Postgres, Redis, HA proxy, whatever. It has got like individual integrations for that, and you can get a lot of matrix. Plus, you can also make your own custom matrix that you want. Say you want something different in each box, you can set up that. Okay, so hosting provider. Most of our services run on cloud. So hosting provider is basically the backbone of our application. If like say GCE goes down, our application will be down, right? So we can set up a monitor on that. It can be as easy as if is the hosting provider up or not, what's the latency, what's the traffic on that. So it's pretty much, that's pretty much it. Okay, external dependencies. So this is like a pretty interesting thing that happened with us. External dependencies can be like a SSL certificate renewation or a domain name expiry. So these deadlines can creep up on you like pretty fastly, and you cannot imagine what happens if, like, say your domain name expires and your site goes down. So we have our own internal tool that we have written. We have a systems portal where we manage all our assets and the timeline on that, and we have set up different alerts on the deadlines on which we need to renew them. Okay, so coming on to the strategies that we can employ while putting in a monitoring system, we can basically mention these three things. Monitoring potential bad things that can happen in our system, monitoring actual bad things like error and exceptions, and monitoring the good things when they stop happening, like say number of booking per second. So if it goes down, you know, okay, something bad is going on. Okay, so something filled up. This is like the most commonly used term when a production issue happened. So it can be like your CPU get overloaded, your network gets saturated, your disk is like, the disk is full. So your okay, your queues are getting full, Redis, RabbitMQ, whatever, and your worker processes are falling behind your master, or the API rate limiting is getting used. Like we use Google Places, and it can hit your API limit if the traffic is a lot. So we need to keep an eye out on each of them. Okay, so some of the actions that we took for that is, like, we usually set up alerts a little bit less than the tipping point, say like 90% of the CPU, so that we have a bit of time on our hand to fix the issue before the system goes down. We usually monitor the unused memory on each of the server application, like the available space on the disk, and the queue size and the storage pool, and the throughput of the services. These 5 things basically give us a overall view of what's going on in a service and if something is going wrong. Cool. So, but say we have like 30 services. Giving each monitor on that, this makes like so many things to monitor, right? And we cannot keep an eye on each and everything. This can result in an alert graph like this. You get an alert every 5 minutes or 10 seconds or whatever. This can lead to alert fatigue. What do I mean by that? Okay, so say if I get an alert in the morning and I keep getting it all over the day every hour, I will start neglecting it. So what will happen is some major alert might fly down the radar, and it can causes the problem further down the line. So what have we done to rectify that? So we have basically divided the alerts into 4 levels. The first one is a warning. Say like on 80% of the disk, you get a warning, your disk is getting full. You have like this much of time to rectify that. Then some are non-critical alerts. Say, okay, some alerts are not, which will take your system down. You have some time, say a day or two, to rectify that. So these comes under non-critical alert. Some critical alerts, and the fourth one is the page. Page is basically, we use PagerDuty for that, and something, if the system is really slow or is down, people get call on that, and we have multiple level of people on that as well. So we use two modes of communication with our developers, say a Slack and a PagerDuty. On Slack, we have different channels for different level of alerts. So basically 4 channels are there, and PagerDuty is for the last one. On PagerDuty as well, we have different level of people, like level 1, level 2, level 3. So if the problem escalates, we escalate the level on PagerDuty, and different people get called. We also have a rotation policy set in, so that not like the same person get call every time. We have like 2 people on call rotation, like everyone has. So that's it. Okay, so now like we have put in all this monitoring, all this alerting. What is it helping us with? The first and the major thing that helps is debugging. And how? So let's say I'm like my server is slow, like my application is slow. Say 5 ms more, it's taking 5 ms more. You can see in the graph at like 9:30, it starts spiking. So what happens is we can set a threshold on that, say, or at 30, if my application takes more than 30 ms for say like 5 minutes, give me a Slack alert. So it sends me an alert. I open up my dashboards. I see the throughput is plunging. So I know something bad is going on. And through the first graph, I know, okay, the blue thing, the JVM is getting slow. So what might be causing that problem? So I go in that particular graph and say that, okay, so these are the external services which my service is talking to. So from this graph, we can easily show that the purple one is the point of failure, and it is decreasing our external call per minute. So through this, we can easily pinpoint the point of failure and rectify that, instead of like running around and seeing, okay, if this is failing, or this is failing, this is failing. We can even go further in that. We can go per transaction level, what API call is getting us slow, what error are happening. So what can happen is, sometime, say you have like 200,000 drivers. Say there is an error, a buggy code. It logs out, say, 500 drivers. It won't show up a lot on your concurrent booking or something like that. But you can easily identify that by the error that you are throwing on your code. So say like the 401 error increases, so you know, okay, something bad is happening. You need to check the code. So last thing, like you need to, after setting up the monitors and all, you need to iterate on them. You need to see, okay, these are some false alerts that are coming. You need to weed them out, and you need to set your thresholds accordingly, and improve your monitoring and that you have. Okay, thank you. That was pretty much it. So if anybody has a question, they can ask.
Hey, thanks for your talk on monitoring and all the good stuff. My question is, do you do any sort of transactional monitoring against your production system? So I understand that Gojek is some like a hyper-local booking thing. So a concrete example is, do you have some sort of monitoring that is continually running, saying that 24 hours a day or whatever I can complete some booking or something like that? And if you do, how do you handle the data or the like side effects created by those transactional monitors?
Okay, so talking in terms of having a dedicated monitor for that, we don't necessarily have that, or say a test running 24-hour, which can say, okay, the booking is getting generated or not. We usually keep an eye out on the error that we are generating on the server and the transactional time that is taking on New Relic. So it pretty much gives us an idea, okay, if something is going wrong or not. If something really bad is going on, we can see a plunge in concurrent booking and all that. So we usually keep an eye out on that. We don't necessarily have a 24-hour test running on a complete follow-up on that. Okay. Yeah.
Hey, I just wanted to know what strategies you use for reducing alert noise. This is something that I'm sure everybody struggles with. So how do you ensure that on a per system basis, the alerts you get are relevant? And how do you continue to tune them and adjust them? Because what error rates you find relevant for one system might not be the same for another system,
Yes,
right?
yes, yes.
So what is your strategy for handling that?
Okay, so we actually have like tagging on our alerts. So each system has its own alerts. Say all the HA proxy alerts will be together, all the database alert will be together, all the application alert will be together. Then we basically see, okay, this box is sending more alert. It's more of like human decision. Yeah,
Trial and error, right?
trial and error, more or less.
And what about the system monitoring and all? Like, what system do you use? What do you
Our monitoring stack consists of New Relic for application monitoring, Datadog for like the box level and any other dedicated metrics we want, PagerDuty for pages, and yeah, that's pretty much it.
Do you do any sort of alerting based on metrics generated from your systems? Like, say, I don't know what your graphic backend for metrics is, but do you do something like that based on your metrics? Like, say, if a collection of servers is having some sort of load.
Yeah,
threshold,
definitely. Say
basically aggregated, like
yeah.
collections.
So, yeah.
Not
So
not
say if our HA proxy has like 12 nodes behind that, and 4 of them goes down, so we basically get an alert on them. Okay, these 4 nodes are down, these 8 are up, and the time is increasing because of that.
Okay, right. And since you have payments and a lot of integrations like that, what happens? Yeah, just one last question. Since you have third parties that you integrate with, how do you handle their going down or being unreliable and things like that?
So for like bank integration and all, we have dedicated tunnels for that, and the most we can do is like monitor that tunnel if it's up or not. If something goes down on their end, we can't necessarily do anything for that.
Hello. Hi.
Yes.
So, you have any consolidated email stuff? Like, if I have 500 server and I have 30 plus service check, I have to monitor every day.
Okay.
And so every time, so one or the other service may go down.
Yes.
So you will get individual alert, or it will be a consolidated alert?
No, we get individual alerts on each of the error that happens. So that's what I said. Like we segregate them on the on application level and component level, and we try to like keep up with them.
Okay. So I could see that you have many tools, right? Third-party tools that
Yes,
you have.
yes.
So how will be the maintenance will be? So
Maintenance in terms of?
like everything is third-party tool, right? You have to pay.
Yeah.
for everything, yeah. So it's a cost-effective. It's not very cost-effective, something like that. I feel.
It depends, right? So it depends on the volume you have. Like for us, it's pretty much it. But we are trying to move on to a lot of like free tools like Prometheus and all that. So we have also our in-house Sentry hosted, which have like 500,000 alerts it process per minute. So we are moving towards that. But initially we could, the best we could do was that. So we opted for that. Any questions?
Hi, this is Kishan.
Hi. Yeah.
I have a question. So when a check fails, like it may be a critical, so do you provide any auto heal feature?
Auto healing, we don't necessarily have a lot of auto healing in our system. We for the alerts which come up on a regular basis, say a system is going down on a daily basis, we can have a cron job on there which restarts it until we solve the problem. So
like what I am saying is, before sending any alert, you can try
Yes,
this.
yes.
Like if it is a Zenit service, right? You can try restarting it. If it fails, then only you send the alert.
Yeah,
So are you trying anything like this?
Yeah, for like process, we have Monit and we have Upstart integrated with. So if the process goes down, it respawns it again, tries for like 5 or 10 times. If it fails, then it raises an alert on our system. So these are like our example of what we have.
And also you showed on graph like for load average, there is a different graph. Memory, there is a different graph.
Yes.
So if at any point of time, I want to check all the 4 components in one graph,
Yeah.
right?
The
Currently,
graphs,
it is
yeah.
difficult. Since there are 4 graphs, it will be a difficult. So if we represent all in one graph, it will be easy for understanding the trend.
Okay, the graphs are different, but the dashboard is same. So you get all the 4 graphs on the same page. So you can correlate
but we
with
need
that.
to check at a different exact point of time, right?
Yeah.
So we need to navigate all the 4 graphs.
No, it is on the same page. The dashboard is the same. So you can look at all the 4 graphs at the same time.
Okay.
Hey.
Hi.
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 Yeah.
For application monitoring, you said you use New Relic.
Yes.
Do you have tried any of the open source alternative?
Not on our production. We haven't.
Okay.
Like on our production, we currently run New Relic. In testing, we have tried like Prometheus and all, but we are seeing how it handles our load and all. So.
Okay. Thanks.
Thank you.
Hey. I'm here.
Yeah.
Yeah.
Sorry.
Could you tell me a couple of concrete points about New Relic, which is different from App Dynamics? I mean, why are you not using App Dynamics?
I don't have much experience with App Dynamics. Like
Okay.
New Relic serves our purpose pretty well. Like it is really in depth, and that's what we opted for. So I don't have a like in depth knowledge of App Dynamics. So
Okay, that's good.
I can look up into it.
Yeah.
Okay.
Okay.
Any more questions?
Yeah. Just before that, sorry. We'll take just one more question because we have to break for lunch. We can discuss further in the open spaces because I think like lots of us have the same issues and like different approaches, so we can have a proper discussion around it with proper time.
Just one question. So what are the benefits of New Relic over other like Grafana or ELK?
Yeah, we do have ELK. We do have Grafana. Like they are being used for different purposes. Like our BI team is using Grafana for their system, and like but we found it was like pretty heavy for them. So and we have ELK for basically for log monitoring. So all our logs from all the system go to the ELK, and you can like pass them or whatever you want to do with them. So ELK is a separate branch which we have for monitoring our errors and all.
I mean, do you see any like advantage over New Relic compared to the others? Like
Compared to ELK?
I mean, in New Relic compared to the others, yes.
Yeah, so like ELK has a different altogether application, right? So you basically get your logs and you can see the number of errors which are happening. You cannot go into a transactional level, say, okay, this API call is taking this much of time, this API call is taking this much of time, or like my basic service is dependent on 4 external services. So how are those affecting my application, right? So
Okay.
I believe that those are 2 very different things.
No,
So-
I mean New Relic over Grafana. Like, what are the benefits here than the Grafana?
It is just a matter of choice. Like
Okay.
I don't know. Yeah.
I mean, I just want to know if there is more benefit than the others.
No, I don't know any of
Okay.
that. If there are any, yeah.
Fine.
I think we can take that to the open spaces again because like there'll be more people who have kind of used it. Can we have another round of applause? This was his first talk and he handled it pretty well.
Thank you, everyone.
We'll be breaking. Thanks, Prashant. We'll be breaking for lunch. It'll be around for 1 hour, so we should be back by 1:45. It's at Seasons Hall. So you have to go in the same direction instead of going out. You just go a bit ahead and take a right, I guess. People who have left earlier, if you see them wandering in the older location, please ask them to join you. Thanks.